I'm Tim Ventura, and we're joined today by Dr. Eugene Podkletnov, a chemist and expert in materials science known for his experimental research into gravity control and shielding with YBCO superconductors. Dr. Podkletnov made global headlines in the 90s for his experiments with gravity shielding in rotating disks made from ceramic superconducting materials. His accomplishments include collaboration on physics theory with Dr. Ning Li's team, consulting on materials engineering with the NASA Marshall Space Flight Center Gravity Research Team, and co-authoring papers on gravitational impulse experiments with Dr. Giovanni Modenese. Dr. Podkletnov graduated from the Moscow University of Chemical Technology, got his PhD and spent 15 years at the Institute for High Temperatures in the Russian Academy of Sciences, got a second PhD from Tampere University of Technology in Finland, and has been featured numerous times in major broadcast and print media outlets around the world. He joins us today to discuss his ongoing research into emerging physics. Eugene, welcome. I've never seen you in person before. This is a tremendous pleasure.
Hi, Tim. I'm also very glad to see you.
It's wonderful, wonderful. I have been waiting. Let me see. I think we've known each other 20 years now. This is the first time we've done a video call. So let me start out. I should ask, you are in Finland right now, and you're in your office there. What have you been doing? Because we haven't done an interview, I think, in about 5 years. So could you help catch me up on what's going on in your life, what has changed, how your research has gone, all of that?
At present I live and work in Finland. I'm connected to Tampere University, so I teach my students and also lead a scientific work. Usually I supervise the activity of some small laboratories who work on gravity all over the world. I also meet my colleagues in different countries. Lately I was traveling extensively, mainly in Europe, but also to China. Sometimes I go to Russia because there are a group of Russian professors who work in this direction too. So my life is full of activity. If we speak about personal life, I can boast that my younger daughter is in high school now, and her favorite subject is physics. And she knows about gravity, everything that is possible to find in the textbooks. And sometimes she argues with her teacher of physics, which is quite natural, but they always come to a good compromise. So that's the situation.
That's wonderful. That's wonderful. I have a 15-year-old daughter as well, and mine just argues with me, though. So let me get into an overview of your work for the audience. There is so much that you've done. You have created such a tremendous legacy of research. So starting out in the 1990s, you were researching gravity shielding with rotating YBCO superconductors. Then in the early 2000s, yourself and Dr. Giovanni Modenese used a Marx generator discharge onto a superconducting emitter to create a beam of gravitational force. And then later, when we spoke in 2020, you had described a completely new experiment using what I understand was an ion-impregnated gold foil on a rotating metal disc that generated a gravitational shielding effect without using YBCO superconductors. So these are three very unique projects, and it's interesting to see this progression also. Have you done any more work on these experiments since we've last talked?
Yes. Before we continue this discussion, I would like to say that we no longer use the term gravitational shielding. It was the term that we used many years ago, because when the objects changed their weight, we thought that it was connected to the gravitational shielding by a superconductor. Later, we came to a conclusion that it is not shielding, but modification of the local gravity field close to our device. And so at present, we use the term modification of gravity. Our first experiments were with rotating superconductors. It was a very useful material, as superconductors allow to obtain any configuration of the magnetic field, and they can freeze it in space so that we could use this configuration. My second experiment was generating of the discharge with Mach generator through a superconductor. And the results were published in 2012. There is an electronic book, which is, I hope this can be seen.
Okay.
This is an electronic book.
Yeah,
And
Gravity Superconductor Interactions, Theory and Experiment.
Our article was titled Study of Light Interaction with Gravity Impulses and Measurements of the Speed of Gravity Impulses. A fundamental work with Giovanni Modanese, and that was, I think, a good achievement with superconductors. And finally, we came to a point where we decided not to use superconducting materials for the special configuration and with our gravity generator. We chose another variant, which is rotating magnetic fields. Of course, at the first stages, we tried to rotate a normal disk. Every metal disk, when rotated at high speed, creates torsion fields around itself. These effects were used by German engineers during the Second World War. They made a whole combination of 3 disks rotating in different directions, and they were able to create the devices that were levitating and propagating in space. According to my knowledge, both American part and Russian part got the drawings of German engineers and tried to replicate, but failed. There is a small secret there, and it took me many years to solve this problem. The point is that the disk should have unbalanced rotation. That means wobbling, if you want. And the speed of the rotation should be big enough because we're working with small disks and small masses. Therefore, we use the rotation of up to 15,000 rotations per minute. And we have a very clear and measurable and observable effect. This is a repulsive force that goes from the disk. So these are torsion fields that the scientists were looking for. Some scientists even now do not believe this. They have their own criteria. But we decided to work with this phenomenon, and we reached some success. Later, again, we came to the conclusion that there is no necessity to rotate the disk, but it is possible to rotate only magnetic fields because it gives practically the same picture. We create vortexes in physical vacuum or ether, if you like, and rotating magnetic fields is gives much better effect, much stronger effect. And if we speak about a possibility of interstellar travel, definitely rotating heavy masses is not a good approach, but rotating magnetic fields is a key to propellerless propulsion.
Well, so that brings us to your latest experiment. You've described using toroidal solenoids with complex windings that are operating near the terahertz frequency range that produce a levitation effect lasting about 15 to 20 seconds before they overheat. So the limitation really wasn't the device, I guess, in terms of the effect itself. It was just heat buildup inside of the coils. You described using copper and I believe copper silver coils for a little bit better conductivity. And I guess your team has solved this issue. And so this is something that you can do better with in the future even. Can you tell me a little bit more about these experiments?
Yes. Toroidal transformers are now very popular in electronics. They are usually winded across some core inside. So we can use a normal solenoid, a normal coil, and then wind a toroidal solenoid around this initial coil. At this combination, electric field and magnetic field do not have the difference of 90 degrees, but they are coherent and they are directed in the same direction. The most interesting part is that, again, we should use the principle that the system should be asymmetric. We have that asymmetric principle in Byfield-Brown experiments. You made a lot of experiments with the lifters, and we have a toroidal configuration, but we decided to change it. So I will demonstrate this drawing. As you can see, so with red lines, we see the central part that is a normal coil. And with green light, we have a toroidal solenoid, which is winded over this normal coil.
Okay.
And it is asymmetrical because if you see that the angle here is not equal to this angle, it's again the key to success. Actually, when we build our current installation, this angle is even steeper. So it's this is a cross section. Of course, it's a simplified view, but it's a cross section of the device that will fly to other planets in some years, I hope. So this is an interesting thing. And again, we use different frequencies, a combination of frequencies, sometimes two different frequencies, with a difference of about from 10 to 11 times. This configuration gives a possibility to use the full force, and when we test the devices with this shape, we have pretty stable levitation force. But of course, the system does not fly entirely into the air. First, it is situated on the table. Then some part of it begins to move, and only one part moves because the other part is heavier because of the wires that go there. The field, the torsion field, is building, and it takes some seconds. And then the whole system goes into the air, and we can keep it there for several seconds. Then we feel that there is an unpleasant smell of burning insulation because we are working at the maximum possibility of our wire. It's in the laboratory, and it takes a lot of time to make all the windings, but this is quite a success, and can and will be used for our future work.
That's that. You know what? I hadn't considered that, but now that you mention it, so every time you burn through the coils, you have to rewind it since it's a custom winding. That's a lot of work for each test, but it must be incredibly rewarding to see it levitate. Now, you had described this as generating what you've described as large forces for levitation. Can I ask how much force have you been able to generate, and how much power do you think it took to generate that effect?
Well, frankly, the system takes several kilowatts,
Mhm.
uh, and we use Tesla technology and the Tesla approach, I mean Nikola Tesla, uh, to for our power supplies, because there should be a special shape of the signals that go of the frequency that we send to these coils. Also, it takes a lot of work to find the resonance frequencies where
Yeah.
the effect is the maximum. Tremendous work. Now we can use the computer programs, but anyway, it's time and time consuming and efforts consuming. How powerful is installation? The fact that the coil, the whole device weighs from half a kilo up to 3 or 4 kilos, and it is able to lift itself in the air, it's quite interesting. So we can't appreciate, give the values how powerful it is, but let's say, as Rolls-Royce, it's powerful enough uh, to be used for practical applications.
Well, and it is so exciting. It's exciting to see the progression of your work, too. As you described earlier, you started out with rotating devices and you've gone to rotating fields. And that is a prediction that many others have made over the years. So it's amazing to see that. And then from your initial, again, what was called gravitational shielding or now gravity modification, from that initial effect, which was a very slight effect, now you have something that is lifting off the table. So this is amazing. This is amazing progress. Let me be one of the first to congratulate you on this because it's absolutely tremendous.
Thank you, but it seems that the progress was fast. I began working in this area 33 years ago, and the first article appeared in 1992 in the journal of, it's called Physica C. And at that time, the article was called A Possibility of Gravitational Shielding by High Temperature Superconductors. So 33 years of work is a big period. And I can't say that this is all I invented or the members of my team. We gathered the knowledge that existed in the world during the last years, and we studied theories, we studied experimental installations, we discussed it with many people, and this is the result and the combination of knowledge from different fields of physics. But I agree that this is the way to follow.
Well, in terms of the physics, one of the things you had mentioned this earlier is you've described this device to me in email and prior videos as a gravitational well. That is what it is generating, where the experimental device continually falls into the well. Again, that's a very relativistic description of the effect. And the reason I wanted to clarify that for the audience is this does not appear to be repulsive effect, right? In other words, you're not pushing against the table, the workbench, or the floor. This is creating basically an area of reduced gravity above the device, and it falls upward into it. Would that be accurate?
Yes, that is absolutely accurate. We don't push this time. This time we have a kind of attraction because the field that exists, or the field that appears over the windings of the solenoids, it's first of all, it can be as big as half a millimeter, it can be 1 millimeter, and then goes up to several millimeters. And this area, from the point of view of physical vacuum, is not so dense as all the area around it. Definitely, this area with less density is filled with the object. So the whole solenoid goes up. And at the same time, when it goes up, it brings this torsion or close to gravity field together with it. So it is moving up all the time and bringing that source of motion together with it. Depending on the on electrical parameters, the field can be bigger or smaller, so we can regulate the speed of the device that goes up. Also, when we speak about the same the construction that we have here, usually this part is steeper, goes here. The vectors of the torsion fields, they're perpendicular to the surface. So perpendicular here, perpendicular here. When we have steep angle here, the device is more stable in the atmosphere, much more stable. So that's how it works.
Yeah, it's absolutely amazing. And, you know, the way that you described this, as well as your prior experiments, this reminds me of so many things. When you had talked about having a wobble in the disk several moments ago, that reminded me of Alexei Chekurkov's Graviflyer, right, which has been out there on the internet for a while. And what you're describing with the coils reminds me in some ways of an experiment that Dr. John Brandenburg did with his GEM theory. So it is amazing to see this convergence, I guess, from different paths of experimentation and research. And, you know, you are right in the middle of it, you know, especially working with torsion physics, which is something that so many different people have experimented with and theoretically modeled. And I think that there are so many unknowns there. But also, one of the challenges that I've seen is the description, the word or the meaning of torsion means different things to different scientists depending on their background and where they come from, right? Even within electromagnetism, I guess, there are different interpretations of it. And so that has been kind of a challenge for people.
That's right. We usually use the works of academician Akimov. He gave the theory of torsion fields. He died several years ago, but he left his scientific school and he predicted many things, but when he was alive, he had no confirmation how torsion fields work. Now we have this confirmation, and it is we can easily reproduce and demonstrate to people torsion fields. It can be organized at any university. We need a good vacuum chamber, a rotary pump, high-speed motor, and the disks made according to our requirements. And we can demonstrate, so this is not a secret, and this is a big breakthrough.
Yeah, it's amazing. You'd mentioned Anatoly Akimov, I believe, and then he had done work with Gennady Shipov, who I've interviewed in the past, and so there is this amazing amount of work there. And one of the things that I understand from the past is during the Cold War, torsion physics research in Russia was very popular. There was a lot of work done in that area. Whereas in the West, that research went in a different direction. And so, from everything I understand, there is still a ton of knowledge, expertise, and information in the Russian scientific establishment that we just don't have in the West.
Not exactly so. There
Mm,
are many similar moments uh, where, if we analyze the theory of Putov, Hayes, and Rueda, the theory of energy fluctuations of vacuum, uh, a lot of things common with the theory of torsion fields. Also, modern scientists call that ether physical vacuum.
yeah.
And a good friend of mine, Professor Paul Violet, published a book called Quantum Kinetics, where he gives the equations for different properties of this physical vacuum, because it can be polarized, it can have bigger density, smaller density. We can create vortices inside this physical vacuum. And so we use this information for our practical devices. Also, speaking about different theories in this field, we also use Maxwell theories and Maxwell equations, but as some professors in Britain provided me with Maxwell equations, which were originally written by him, not the simplified version, simplified by Heaviside, which is now being taught at all universities. So there is a big difference, and I'm thankful to my colleagues for their help. But speaking about theoretical approaches, I should say that during the last 50 years, uh, the governments of different countries and scientific associations spend a lot of money in the field of theoretical gravity research. The money was given in the United States, in Russia, in China, in Italy, in Britain, and also in Europe by European Space Agency. There were many experiments that were organized in NASA, in some small laboratories, also in military laboratories, in European Space Agency, British Aerospace. And we now combine the theoretical knowledge that exists in this field and experimental knowledge. And the cost of all the experiments and theoretical research during the last 50 years was over $2 billion US. So it's a great amount of data, and this data is crucial for our advance in this field. So when we now approach some investors and say we are ready to work, they usually look at us and say, well, you come empty-handed. And we say, no, we come with the knowledge, at least 2 billion in knowledge, plus our experimental experience. So that's the situation in this field.
Yeah, there's so much that you are drawing from. There is an incredible legacy. I'm actually working on, as a side project, I'm doing a write-up on a timeline of superconductors and gravity. I had a short version, and I have been using AI to go through old documents and pull out information. And I mean, dozens and dozens of pages of just references, you know? There are so many papers that have been published, experiments that have done, and it's been bits and pieces here and there. And so for you to be able to bring this together is absolutely tremendous. Now, I wanted to ask if there have been any other anomalous effects that you've seen with the new experiment, such as like red or blue shifting of light, gravitational lensing effects, or possibly even small changes in timekeeping devices. And the reason I asked that was I thought, if this really is a gravitational effect, it would be interesting to see if you start to see some of these other relativistic changes happen.
Well, all the effects you are talking about are usually studied by astronomers because they require very big distances, and I was not concentrated on these things. The science is too profound in this field, and I'm usually I regard myself as a person who makes the experiments. But my friend, a good friend of mine, Giovanni Modanese, he knows all the theories, and we both do not believe in time travel. But he says, Eugene, we should keep our research in such a way that it doesn't contradict Einstein's theory. And we analyzed all our activity, all our results, and came to a conclusion that it is in good accordance with Einstein's theory. We do not contradict him. We also do not contradict Newton. On the contrary, we studied the works of Newton, and it helped us a lot.
Another thing that I wanted to ask about was, again, you have moved away from using superconductors. And I recently visited Glenn Tony Robertson's lab in Huntsville, and I was able to see his work with superconductors. I did learn a couple of interesting things there. There was a rumor that they had attempted your experiment with gravity shielding and didn't see results. And he clarified for me, NASA never attempted that experiment. They ran out of funding before they were able to try it. So that is on his list. That's one of the things he's working with. So it's good to clarify that with you. The NASA never attempted it. Your results still stand and still need experimental replication and validation. The other thing that was interesting was when I met with him, he showed me how difficult YBCO superconductors are to work with. They are heavy, they're brittle, very difficult to keep cool, and very difficult to manufacture. And then on top of that, there was a melt texturing process that he and others have experimented with. And I don't think anyone other than yourself has been able to really perfect that. So I wanted to ask, are YBCO superconductors in some ways an outdated technology just because they're so difficult to work with?
In my opinion, high temperature superconductors are still very useful. Speaking about the experiment, for 3 years I was a consultant, a scientific consultant for Marshall Space Flight Center in Huntsville, and there were practically two groups there. One was the own group of NASA, and that was called the Delta G experiment. The other group was at the University of Alabama under the guidance of Dr. Ning Lee. And when I was working there, I was hired via subcontractor, which is called Superconducting Components, and the firm is in Columbus, Ohio. So we collaborated with all these groups and also used the help of Argonne National Laboratories. And that was a nice period, but a very difficult work. Also, people at Marshall Space Flight Center are a bit busy with their own experiments. Every person in NASA has 5, 7, 10 projects running simultaneously, which is not good from my point of view. all the experiments of that time were documented, and there is a documentary made by German scientists, German producers, and that was Klaus Simmering. And in this video is available on the internet. It's in German. It was made 26 years ago, and it gives you a direct picture what was achieved at that time. And David Noever was responsible for Delta G project and all experimental data in NASA. So a brilliant scientist, and even in the film you can see that how he measures the anomalies in gravity on his gravity equipment. So some small effects they noticed, but they were working with a very small disk, the small in size and diameter. So that's why their their results were so little. But Ning Li, an outstanding professor of physics, a very bright lady, she made her own experiments at the University of Alabama. Mm. And at first she succeeded getting money from NASA, but then NASA refused the funding and she had to go on her own. But her brother gave her a present, like $500,000 for the continuation of her experiments. It's all in the documentary. And she managed to repeat my experiment in a full scale. When she repeated all the experiments, the funding to NASA was stopped, and the whole information, together with all the equipment of Ning Li, was transferred to the Department of Defense, and she became a scientific director of their laboratory and continued working in some secret atmosphere. But scientists never obey the formalities. And when even working for the American military, she sometimes discussed several things with me. She used to give me phone calls, and we discussed it. We exchanged emails. And the most interesting thing I remember from that time, if a phone call comes during night time, that is definitely Ning Li with her problems, because she could not remember all the time then when it is day in the United States, we have night in Europe. But they reached a certain success, and I don't know the details. Anyway, that was a very useful period of time, and the work with superconductors is, of course, a good thing to do.
Okay, so there is still merit to experimentation with those, although I think that the work you're doing with solenoids, as well as the work you did with the gold-covered disk, is incredibly interesting. And I love the fact that you have delved into Akimov and torsion physics, because I feel like that is something that really deserves more attention and more investigation. And so these are really, really exciting areas. So let me see. Again, you have worked with so many of these big figures: Dr. Ning Li at AC Gravity, Glenn Robertson and the NASA Gravity Research Team, Ron Kozer, you mentioned him, I believe David Noever. You've also worked with Dr. George Hathaway, Dr. Giovanni Modenese, and so many other people. You were part of this remarkable community that is developing this. Now, these are just the Western scientists. There are also many scientists in Russia that you're working with, right? And one of the challenges has been these communities don't talk to each other as much as they could.
Yes, that's right. Unfortunately, Russian professors sometimes also work on closed projects, and they are not exactly the experts on gravity. Some of them work with spaceships, some of them work with electronics, with satellites, some work with solenoids, some work with high voltage discharges. So I can't say that I'm an expert in every field. So I'm not afraid to come to them directly and ask, I don't know this. Please explain how it all happens. What is the mechanism, how we can increase the parameters and so on. Some of the professors occupy high positions at Russian universities, and it's not good to uh, pronounce their names openly. I didn't get the permission. But from my experience with Western technology, I also have a lot of friends in Great Britain. I go there rather often because the flights are cheap, not as to the United States. And some professors in Britain support me officially. But when I come, sometimes they say, Eugene, please forgive us, for we have sinned. And some people asked about your experiments, and we gave a negative opinion because we remember Professor Laithwaite, who was thrown out of the Imperial College, and we want to retire in honor. So please forgive us. And of course, I forgive them. Speaking about my activity in Canada, I was cooperating about 2 years with George Hathaway. He is an outstanding engineer. He had a nicely equipped laboratory in Toronto. And for 2 years, we were working and we understood each other perfectly. And we got many interesting ideas, and he built very good installations. He is a mechanical engineer by.
If it's okay, I wanted to ask about funding because you have a startup company in place, from what I understand. You have projects that you want to move forward with. Have you been searching for funding sources to develop like a craft, or are there a series of experiments? What is your approach there?
Funding is, of course, extremely important because our plan was to create an international laboratory, busy mainly not with science, but with engineering. So we have completed the stage of science and would like to move to engineering. The problem of funding in the United States is a bit difficult because people do not understand the scale of this research.
Yeah.
They think it is one of the small projects made somewhere in the basement or in the backyard. And sometimes people ask, Eugene, can you make a small model of your device and can you demonstrate it to us? The small model will cost much more than the real one, and all the equipment should be practically the same, so it's difficult. But what is a bit surprising that sometimes people say, we can find money, but you should, Dr. Podkletnov, you should send us all the documentation, the detailed description of your installation, calculations, drawings, everything. Then we shall analyze it. Perhaps we shall replicate it in some. And then maybe if we need your help, we'll give you some funding. The approach that does not work.
Yeah.
At the same time, I was approached by a Chinese businessman about 5 years ago. And the point is that they require no proof. They analyzed all the situation with their scientists, and they are good. They are really good. They have money. I asked about 200 million. They said, oh, we can double this, but you should make everything during 1 year. And I said, guys, it's absolutely impossible. I'm a hardworking person, and then they practically agreed to my conditions, but then COVID came and this everybody was sick, so China was separated, and we had to stop this activity. At the same time, if we ask, do American people have enough money? Oh, yes, definitely. Marshall Space Flight Center has a budget of $5 billion every year. So if we ask 50 million per year, and for the International Laboratory, somehow it's possible to find it. I think that our purpose is to find a wise investor. That means a person who understands what this technology can bring to the world and to him personally. And wise means he's patient and will wait for 5, 6, or 7 years. I think that we should, as scientists, we should work with the investors, explain to them what, when, and how, make it absolutely transparent. But I'm a scientist, so I need some help from you, from other people who are busy, who are fans of this field. Maybe they could find some wise people. I'm sure it can be done. It can be done, both in the United States, in Europe. So,
that is one of the reasons that I'm so excited to be able to help you get the message out there. I mean, if anyone deserves the opportunity to put together a research lab, it's you. You have over 30 years in this area, and you have worked with so many of the key figures, right? People like Dr. Ning Li, then as well as high-frequency gravitational wave researchers. A lot of those figures are no longer with us. You are still here. You have the expertise, you have the knowledge, you have the connections. So, again, I am incredibly honored to be able to help you get that message out to people. So thank you for that opportunity.
Yeah, let's hope for the best.
Well, Eugene, I should probably close for today. I'm more than happy to do future interviews with you. I would love to invite you back. While we're recording, I will get that on camera so people know that I am ready, willing, and able. And I guess I should close by asking, what is coming up for you in the next few weeks, next few months?
Well, that's a good question. But the answer is very simple. I consider myself and my colleagues and people who work in this area to be common, normal people. That means we are honest, hardworking, kind, but we have a dream. We have a dream to make a continuing mission, to explore strange new worlds, to seek out new life and new civilization, to boldly go where no one has gone before. And this is a dream of American people. This is a dream of people all over the world. In a way, even Elon Musk is inspired by this dream. So maybe his help would change the situation. I know that our road to success will be extremely difficult. But I want to use the support of good people from all over the world. And I'm absolutely sure that this is possible. And my feelings, deep in my heart, I do believe we shall overcome someday.
Wonderful.
That's it.
Well, Eugene, let me thank you again so much for your time today, sir.
Thank you, team. I appreciate your efforts, what you are doing with the conferences, how you keep this site, and thank you for your tremendous work.
I want to thank everyone in the audience for staying tuned for this remarkable opportunity to hear updates from Dr. Eugene Podkletnov. And now I want to share with you a video that he sent me in preparation for our interview, where he describes even more about his latest research.
Hi, team. It's always nice to see you again. As always, you are doing a great job. I'm always glad to greet all people who are watching this site, people who have a dream to go to other planets, and I hope in the nearest future it will become possible. Well, speaking about the journey to the world of gravity, no, it was not my choice. I never dreamed that I would ever study this field, because by my education and professional training I am an expert in material science, chemistry, partly physics, but gravity, it was something extraordinary. I can't say that it was a coincidence. First of all, because I don't believe in coincidences, and second thing, that there are too many aspects that are combined in this research. So no, it is not a coincidence, but you know, God works in mysterious ways. Therefore, everything seems to be planned nicely, or not so nicely, in a better world. How it all began. I'm studying gravity for more than 30 years, actually 33 years. My first article appeared in 1992 in the magazine of Physica C, and the article was named "The Possibility of Weak Gravitational Shielding by High-Temperature Superconductors." And at that time I was working at Tampere University of Technology, working with superconductors, both bulk and films. The phenomena that we discovered was quite unusual, and we were trying to get some explanation, theoretical explanation, but the subject was too complicated and we could not find any good explanation. At the same time, and maybe it's a coincidence, in the United States, at the University of Alabama, Dr. Ning Lee and Dr. Douglas Thor were studying and were preparing a theoretical platform, and they were trying to connect electromagnetism and gravity. And they studied solid bodies, and they practically made a revolutionary theory. But they were lacking the experiment, and it was difficult for them to go on with their theory. Luckily, they found my article. At that time it was already published in, another article was published in Los Alamos database, and they organized joint research with the specialists from NASA. The experiment was called Delta G. It was a unique experiment, and one day I got a phone call from Ning Li, and they offered me to participate in this experiment, to come to the United States and to be a scientific consultant for this project. It was a nice time, first of all taking into consideration that the whole initiative for this project came from John Glenn. I met him several times and he helped me in difficult critical situations at Marshall Space Flight Center. Speaking about NASA, the team was really good. I have the warmest impression and very good memories about that time. Really nice team. I worked with Ron Kosor, Tony Robertson, David Noever, and a group of engineers and scientists who were experts in their own fields and dedicated a lot of their attention and efforts to this project. The reaction of the scientific community at that time was different. Some scientists who belonged to an old school said it was all nonsense. Absolute nonsense, impossible because it is impossible. To argue them or to give several proofs was absolutely impossible. There were also young scientists who supported the idea. Young people are also, they're very active, they don't have any dogmatic rules, and they do not feel the press of the politically correct science at different universities. So they definitely welcomed this work. But also there are scientists who are responsible for the progress of human civilization, for all that is happening on this earth, because they are wise and their knowledge in different fields causes deep respect. So I'm very much indebted to the help of Putov. We exchanged several emails, we spoke on the phone. He always said that this direction, experimental gravity research, is a great thing to do. And also his theory of energy fluctuations of vacuum was very helpful to us on the later stage. Also, some people, some well-known scientists like Jack Sarfatti, this name is known in the United States. He also appreciated this work and supported me. And in general, Jack Sarfatti has a reputation of a slightly crazy scientist, but everybody respects him because he is really wise and his knowledge goes to the most profound levels. So I'm grateful that he paid attention to this work. Speaking about Europe, well, I have a very good friend of mine, Professor Giovanni Modanese, from the University of Bolzano in Italy. And from the beginning, he gave theoretical explanations to all experimental results that we got, and we published several articles together. He is a brilliant mathematician, by the way, and he is familiar with all existing theories of gravitation, so he helped me to study many things. Also, at present he is considered #1 in the field of quantum gravity. It's a separate science. We'll maybe discuss it a bit later. And if we speak about the attitude of common people and media, the attitude of journalists was different. Some supported me, some were against. Usually they could not have their own opinion because the subject is too difficult. But sometimes they asked for the opinion from the leading professors in Oxford, Cambridge, Stanford. And depending on what they heard, they gave their opinion. So some were for me, some were against me. Actually, I forgive them all for those mistakes, technical mistakes that they made in their articles. But I'm grateful to them as they caused the interest to this problem. Without this interest, it's difficult to work. Common people are our neighbors. They are practically always honest, hard-working, with open heart, and they always welcomed me. I got a lot of letters, and I continue to get a lot of letters, emails. People want to go to other planets. They want to boldly go to where no one has gone before. And they somehow feel that this is the only way to fulfill their dreams. That's why they supported me, that's why I understand them, they understand me. And I'm trying to surprise them even more. How gravity research is related to different aspects of modern physics. The base theory. A very difficult question. Not because it is difficult, no, I know all the answers, but within the frame of our conversation, I won't be able to explain everything and to answer all the questions. But let's say that when working in the field of experimental gravity research, when trying to build a gravity generator, which is the heart of a future flying saucer, made man flying saucer. There are many aspects of physics that we should know in detail and take into consideration. That's why I never work alone. I have a team of people who support me with their advice, with their clear vision, sometimes only in their field, but that is quite enough. So there are people from different countries who support me. So in order to be successful in this field, of course I had to study different approaches, theoretical approaches to gravity. It was a very hard work. The subject itself is difficult, a lot of mathematics. Sometimes there are big contradictions between the theories, but what seems to be important Only combining various approaches, various experimental approaches, we can understand what is going on and somehow try to understand the mechanism of gravity. There were different approaches in history. We know the works of Byfield Brown. I remember Tim Ventura also managed to build very interesting devices. So it was electrogravity. We know the works of John Hutchison, who used mainly electric fields in his laboratory. There were the works of Professor De Aquino from Brazil, where he used high-frequency modulations and antennas in the shape of toroid. We have our own experiments with high-temperature superconductors, and all these experiments are based on the same principle. They use the ether. The term is not new, it appeared many centuries ago. Modern physicists usually call it physical vacuum, and the idea is that the space, even inside deep vacuum, it's not empty. It's filled with very small subatomic particles. These particles have very small, sometimes small, sometimes a bit longer lifetime, and our matter is born from these particles, and then when it is deteriorated, again it returns to the state of these particles. Some scientists still deny the idea of physical vacuum, but I'm quite satisfied that the scientists in Russia accept this idea. Helputov accepts this idea, and many serious scientists also accept this, including Isaac Newton, who wrote more than 400 years ago that, in his opinion, the interaction between two bodies, also celestial bodies, without any intermediate matter or media between them is absolute nonsense. So, I believe him. I spent several weeks at the library of the British Museum, studying the works of Newton in the original, Xerox copy, of course, but it was a nice experience. I became much cleverer, I hope. If we speak about Einstein, in his earlier works, he accepts ether very well. Then for some time he rejected the idea and said that the vacuum was entirely empty. Then he came with the idea of space-time continuum and returned back to the idea of ether, because he explains gravity as bending of the space-time continuum, but if there is emptiness inside, there is nothing to bend. So without ether, the explanation becomes impossible. Now there is a certain interesting aspect in this field. We know electric field, magnetic field, strong field, weak field, and gravitational field, and so on. Not so many fields, but as we found in some old books translated from Sanskrit in India, there are many types of fields. The general, they say about 36 fields, including force fields, biological fields. We know only part of them. There are some discussions in scientific literature about torsion fields. So torsion field is a field that is created by a rotating body. The most intensive torsion fields can be obtained with the rotation of metal bodies, but practically every body, when it is rotating at high speed, produces torsion field. Some people would say we have no proof, but I have proof. I managed to build several installations, so this experiment can be easily reproduced at any university where people have a good vacuum chamber, a rotary pump, a high-speed motor, which allows us to reach 20-25,000 rotations per minute, and a disk made according to our specifications. 5 years ago, it was the last time when I reproduced this experiment in Czech Republic, in Prague, together with Professor Jan Drak, and so just demonstrated people that torsion fields exist. In Russia there is a whole theory of torsion fields produced by academician Akimov, but at the time when he was alive and he made his theory, he had no experiment. Now we have the experiment, and his theory can be easily proved, and we use this theory to go on with our research. Because in many aspects, in our opinion, torsion fields are similar to gravity fields. Maybe not entirely similar, but in many aspects they are. Combining all this information that we have and also applying the knowledge of different areas in modern physics, because when I work with, let's say, gravity generator, I need people who know solenoids, who know high voltage discharges, who know material science, cryogenics, thermodynamics, lots of things. So combining all this and using different theories from Putov's theory of energy fluctuations of vacuum plus Russian theory of torsion fields, we can create really amazing things. The breakthrough in our work came when we were first rotating metal disc under the conditions of high vacuum with high speed, so we could show and measure and demonstrate to everyone the force field that it produces. Later we came, and by the way, this principle was also used by German engineers during the Second World War. They made flying discs. So now we know their secret, because the drawings of the installations are available in Russia and they are available in the United States, but they don't know the secret. The secret is the unbalanced rotation. I might return to this later if there is a certain interest. Now we decided not to use rotating objects because it's bad for interstellar travel. Causes vibration and different effects, it's not good. We decided to rotate magnetic fields, and the rotation of magnetic fields creates the effect which is practically the same, but can be much more intensive. So the levitation force of the device using rotating magnetic fields is at least 10 times more than with a disk. If we speak about rotating magnetic fields, the interest to this problem was pretty big in the United Kingdom when Professor Searle published some of his results, and at present there is a big interest from China. They have a certain group working with, according to the technology of Professor Searle, but using modern materials, and they made some success under normal conditions, so perhaps they would use it in space. And again, the secret of this solution to rotate magnets or to rotate magnetic fields. When we rotate magnets, we should create unbalanced rotation. That is the key to success. When we deal with rotating magnetic fields, we should use asymmetric configuration. Asymmetric configuration similar to a certain extent to what we have with Biffle-Brown. And if there is no asymmetric configuration, there is no disruption of the flow, to tell you in... Well, better I don't discuss this at present, because otherwise I will tell you all my secrets, and that would be a disaster. What else? It seems that Newton and Einstein were the only people who were interested in gravity. The rest of the world prefers to use airplanes, trains and submarines, and that is all. Except Elon Musk, who is an outstanding person, and I'm a great fan of his. But the question is about Newton and Einstein. So, as I already mentioned, Newton was absolutely sure that there is some substance, some thin substance that fills all the space around us, and only interacting with this substance all the planets and all the move, and galaxies move, and everything that we have in atomic structure is born, and so on. Also, speaking about Newton, if we look at modern books, textbooks for school children and for students, we will see that when they formulate the law of Newton, they will say that according to Newton, all objects that are thrown into the air have a tendency to fall down on the earth because they are attracted by the earth. And that is not the case. Newton wrote not because, but as if. Don't you see that there is a big difference between because and as if? So the law of attraction is only our desire to explain how it all goes. The mechanism of gravity in many aspects still remains unknown, but there are many things and many characteristics of ether that we can use to our advantage, and we can build flying vehicles and use them for the exploration of space and on the Earth as well. So I do not go against Newton in anything at all. And people who usually accuse me of going against Newton, they never studied the works of Newton in the original. So before accusing me, please go to the British Library, to the library of the British Museum, find the materials, and then we can talk. Also, British scientists are very conservative. So Professor Laithwaite, really greatest scientist of his time, discovered a lot of nice things. They also accused him of going against Newton. He was fired from London Imperial College. What can I say? Brits are Brits. No offense, please. Now, if we talk about Einstein, I already answered that. Sometimes he was accepting ether, sometimes he was denying, but all his theories prove or demand or require the existence of the ether. Otherwise, everything becomes nonsense. Also, if we speak about general theory of relativity, not special, but general, general theory of relativity describes relative motion, that is, motion of one object against another object. So what we are dealing with is rotating of the object around its own axis. It's not relative motion, it's absolute motion. And absolute motion cannot be described by the theory of relativity. It's not applicable. Speaking about special theory of relativity, there are some let's say, points that Einstein took into consideration. From the beginning, he said, let's admit that the life of speed is constant, so on and so on. There are several aspects there. If we follow these aspects, there might be some contradictions. If we understand that the theory of special relativity is in great contradictions with quantum physics, then we again come to a conclusion that maybe this theory is not applicable to the structure and to the properties of ether. The speed of gravity is an interesting subject. Some people say that it is equal to the speed of light. Some people say that it is practically instant. In our experiments with pulse gravity generator, we found the speed of gravity to be equal to 64 C. It was a very serious work. It took several years of the work of my group and lots of my free time. We got the most unique devices from Paris, from the we used atomic clock, we used some other devices. I'm grateful to the people who helped me with this, and under normal conditions we made several experiments with very serious scientists. good physicist. I don't consider myself to be a physicist, I'm a chemist. So I'm allowed to make mistakes. They are not allowed to make mistakes. 64C according to our measurements. At what stage we are? Let's say that in order to study gravity, to understand all small details and so on, we need years and years of work. That would be unacceptable entirely. So I spent 33 years working in this field. Me and the members of my team and all the scientists who are on our side of the barricade, we now have tremendous knowledge. In fact, we collected the knowledge of different groups in different countries for the last 50 years. Also, we studied many things that were made before that, both in theoretical aspects and practical aspects. Now we think that we are able to create a working prototype of an artificial gravity generator, which will be the heart of the flying vehicle. This flying vehicle will be able to propel in normal atmosphere, in space, and underwater, with the speeds exceeding all possible existing equipment on the Earth. The scientific stage of this experiment is practically completed. We have the existing technology and the knowledge how to build such devices. We base our knowledge on the fact that in the laboratory we made toroidal solenoids of pretty complex winding, pretty complex configuration. They demonstrated the ability to levitate, and the point is that when we test these things in the laboratory, we work at the maximum possibility of the what the wire can stand. We use copper and copper-silver wire alloys, but our device was able several times to levitate for only several seconds. Let's say 15 seconds, 18 seconds, 22, 23 at maximum. Then we had that the insulation was heated to a big value, and we had shortages in the circuits, and the work of the whole year or 2 years was ruined, because and our technicians were terribly disappointed because they worked very much, they showed it. But actually, to organize the cooling of these systems, to use another wire, to use another configuration, it's absolutely possible. So the existence of the solid levitation and big values of levitation force we managed to get at the laboratory. So now we think it's possible to go to a larger scale, to attract people, to create that artificial gravity generator. if you speak how to understand how all this works, let's say that when we are rotating magnetic fields, under certain configuration and combination of these fields, we can obtain the vector of electric field and the vector of magnetic field, which are usually at 90 degrees. We can make them coincide. They go in one direction. So this is important. Second thing important, that we should use the frequencies that are close to terahertz radiation, and we should also use what we call it asymmetric configuration. The combination of these parameters give us a possibility to create small tornadoes or vortexes in the ether, and these vortexes first of all penetrate everything, but they at initial stage they go slightly over the surface of the device or the surface of the windings of our solenoids. As soon as the whole installation is covered with these fields, and we can control these fields and direct them to any direction in space that we want, we get a levitation force. So our whole device is going up, and it brings that field, that small field, let's say 5–10 millimeters. Even slow, if it is 1 millimeter, it's quite enough. So the device brings this field with it, and it continues to go up, because this small layer means that we have a kind of gravitational well, and our device is moving in this well, so as if falling on the bottom of this well, which we observe as the device flying up in the atmosphere with a big speed. So that's how we imagine it. Speaking about the difficulties in this field, practically I never got any funding to organize this work. So all these years I was organizing this work using my own resources, which are absolutely limited. I am not rich at all, or penniless, whatever you choose, and using the laboratories at different universities, the experience of other groups, the help of many people, common people, scientists, just good, honest people. So if we find a possibility to invest good money into this project, the result is guaranteed, and we can reach amazing heights in this field, I'm absolutely sure. So, as I said, the scientific stage of this experiment is over. It is successfully completed. We go to the engineering stage, but you can imagine that it's a very serious work which requires the help or joint work of physicists, expert in chemistry, material science, experts in avionics, people with good mathematical abilities, computers, because there is no one we can ask for an advice. It's an entirely new pioneering field. And we clearly understand that the expenses will be pretty big. If we speak about, let's say, Boeing 747, and we want to increase slightly the length and to increase the power of the engines, and just to put 8 or 6 rows of passengers inside to make it slightly bigger. Planning all this, calculating and making the first plane will take $200–300 million US dollars. Only this thing. And we are dealing with a new technology which is much more complicated. So we are looking for wise investors. I don't want to use this site for attracting people, but hopefully, and this is the only rational decision, if people really want to conquer space and to go to Mars and other planets, in our opinion, it's the only solution. Artificial intelligence, it's the topic which is now overwhelming and filling all the internet. Sometimes people ask artificial intelligence different questions. They get good answers, sometimes very detailed answers that can help people. In our case, the lack of knowledge, the lack of data doesn't allow our friend artificial intelligence to create the device and to give us the advice in what field to propagate. But at the same time, you can see the cities of the future built by artificial intelligence. There are many nice films on the internet, and there are different vehicles flying or hovering there. But how they do it, it is assumed that they have either anti-gravity technology or artificial gravity. I prefer the term artificial gravity. How to make this? This task was left to us, so we will try to fulfill the needs and the expectations of common people. The future of the world, the future of the world will definitely change, because instead of the planes, there will be flying discs all over the Earth. These flying discs will go to the Moon, to the Mars, to other planets. They have certain advantages over the existing fleet, because they produce no noise, they produce no heat pollution, they produce no radioactive pollution, they have no toxic exhaust gases, so they are really what our civilization is hoping for. They will be pretty reliable and rather cheap as compared to all current methods of transportation. And finally, I would like to express my sincere gratitude to Tim Ventura, who is an outstanding person, very kind person, attentive, thinking, for his tremendous work in this field, because American anti-gravity is known all over the world. This is the side, I should say, at the sharpest end of modern physics. And Tim makes really a great conference, organizes this conference, and so all the people can share their opinion on different aspects of modern physics. And I watch these presentations. They help us in many aspects, and without the common efforts of the scientists, all our progress would be impossible. So thank you, team, for being the best of the best. And as always, may the force be with you. I also think it would be interesting for our viewers to find the books which I use every day in my work, and which each of these books gives a grain of knowledge. And by collecting all these grains, we'll make a nice porridge, I hope. So first of all, the book by Paul Laviolette, Secrets of Anti-Gravity Propulsion. It's pretty thick, very clever. We discussed many aspects of anti-gravity propulsion with Paul. He was a very good friend of mine. And he passed away, and that was terrible hit for me. So also Paul published a book which is called Subquantum Kinetics. And in this book he gives the equations which describe the ether. The ether or physical vacuum, because the ether can be more dense, less dense, it can be polarized, it can be organized in such a way that there are different vortexes in it, because the main idea of gravity propulsion is the sentence which comes from very old books: swirl and you shall levitate. Swirl and you shall levitate. I also use sometimes the approaches of Nikola Tesla. So there's a nice book by Tesla. Sometimes I try to understand how ether works, and I'm not afraid to look into the books which are not textbooks, but which have some deep knowledge inside, like this one, for example, Occult Ether Physics. Also, speaking about gravitation, we should definitely know the classical approach to gravitation, because without it, the understanding of all the other things would be impossible. So there is a small book called Gravitation, but a very good one. Among theories of gravitation, there are many popular books. Sometimes they are very useful. Sometimes there are very good ideas there, and the writers who wrote these books, they're mainly journalists. They do not understand how precious this work is. So there is a book called UFOs and Anti-Gravity, Piece for a Jigsaw. Pretty thick, I also use it. It's not bad. Then there is a book, Man-Made UFOs, and here we have what we inherited from German engineers during the Second World War. Again, it's a lot of material and it's all useful. And there are books that are at the border of serious and not serious, and again very useful, like this one. And finally, every scientist has some complementary material that helps him to achieve good results, and I also have this. It's called the Anti-Gravity Handbook. Lots of good ideas. There are many other books, articles, ancient manuscripts, and what I am also collecting, these are the conversations with my colleagues all over the world. We want to make it a better place, and we will succeed.